Welcome back, my dear students. So in this class we will see about the continuity equation in three dimensions. So in the last class we have seen the continuity equation in two dimensions. What is that? A1 V1 is equal to A2 V2. Now the same continuity equation when it comes to three-dimensional element, then what will happen? So as it's same as what was the concept in 2D, same concept will be in 3D also. What is that? The same basic principle of conservation of mass. Okay, what is conservation of mass? I have already told you. So with regard to that, we will see the continuity equation in three dimensions. So when fluid flow through a full pipe, the volume of fluid entering into the pipe must be equal to the volume of fluid leaving the pipe, even if the diameter of the pipe vary. So what they are telling? They are actually telling the law of conservation of mass. Okay, the volume of fluid entering into the pipe must be equal to the volume of the fluid leaving the pipe. One pipe ಒಳಗಿನ ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಆಫ್ ವಾಟರ್ ಹೋಗುತ್ತೋ ಅದೇ ವಾಲ್ಯೂಮ್ ಆಫ್ ಫ್ಲೂಯಿಡ್ ಹೊರಗಡೆ ಬರಬೇಕು ಅಲ್ವಾ. ಸೊ ದಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ದ law of conservation of mass. Okay, so based on that we have to prove, or we have to tell that the continuity we have to write the continuity equation in three dimensions. So therefore we can define the continuity equation as the equation based on principle of conservation of mass, right? So same volume of fluid is entering the pipe and same volume of fluid is leaving the pipe, so the conservation of mass is satisfied like that. Now therefore for a flowing fluid through the pipe at every cross section, the quantity fluid per second will be constant. So therefore it is obeying the principle of conservation of mass. Then we can take that flowing fluid through the pipe at every cross section, the quantity of fluid per second will be constant. Same ಒಂದೊಂದು per second per constant ಅಂದ್ರೆ ಒಂದೊಂದು ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಅಲ್ಲೂ ಆ ಪೈಪ್ ಅಲ್ಲಿ ಬರೋ ಒಂದೊಂದು ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಅಲ್ಲೂ the amount of water, the volume of water will be same ಅಥವಾ equal. Okay, when we compare with the cross section it will be equal ಅಂತ ಅರ್ಥ. So when the fluid flow through full pipe, the volume entering to it and leaving to it, if it is same, means the volume of the fluid at every cross section will be constant. Okay, now what we can tell, if that is constant, we can tell that it is obeying the principle of conservation of mass. Okay, now we will see how it can be derived. So what we have to do, anything before derivation, we have to the fluid will flow through the pipe. Okay, the fluid, we have to imagine that the fluid is flowing through a pipe. So same amount of quantity, right? What is entering the pipe, the same amount of quantity is leaving the pipe. So entering is equal to leaving. Okay, so we can't analyze the full pipe. What we have to do, we have to select an element. Okay, we have to select an element from that, and for that fluid element we are taking into consideration. Fine. So same thing, in the fluid pipe ಅಲ್ಲಿ ಒಂದು small element ಅಂತ ತಗೋತೀವಿ, ಆ small element ಗೆ ನಾವು apply ಮಾಡ್ತೀವಿ. So I take this as an element. So element A, B, C, D is a fluid element. Okay, this element A, B, C, D, E, F, G, H is the fluid element in three dimensions. So X direction allo ide, Y direction allo ide, Z direction allo ide. Okay, so here Z is taken as vertical direction, no problem, any direction, just we have to be good in maths, that's enough. Okay, so now what we have to do, consider a fluid element of length dx, dy and dz in the direction of x, y and z. So we consider a fluid element, this one is a fluid element. In x direction it is, the length is dx, in z direction the length is dz, and in y direction it is dy. Okay, so we have to consider the fluid element of length dx, dy, dz in the direction of x, y, z. Okay, so let u v w are the inlet velocity components. So in x direction, what is the component? We have assumed u. In the y direction it is v, and in z direction it is w. And these three directions are mutually perpendicular to each other. Correct? So now mass of the fluid entering the phase ABCD. So mass of the fluid. So mass of the fluid entering the ABCD. So this is the surface. Seeing here, this one ABCD. The mass of the fluid entering the phase ABCD is equal to what? Density into surface area. Okay, we have to take the density into surface area. That is, density is what? Rho. Velocity in x direction, okay, u. So what is we are calculating? We are calculating the mass of fluid element, fluid mass of the fluid in the element entering the phase ABCD, right? So rho into u into area of the ABCD means surface area to take, that is length into height, that is in the direction of x, right? x ಅಲ್ಲಿ ಏನು dx ಇದೆ ಲೆಂತ್, ಓಕೆ. z ಅಲ್ಲಿ ಏನಿದೆ dz ಇದೆ, y ಅಲ್ಲಿ ಏನಿದೆ dy ಇದೆ, okay. See dy. So when we take the mass of the fluid entering ABCD, A, B, C, D, what we can tell? So we can calculate the BC. Okay, BC is what? Our length, and also DZ is our length. So DZ is our length, this, and BC is our length. BC and CD, it is the surface area, that is area of ABCD. So rho into velocity in x direction is u. Why velocity in x direction? Because we are calculating in x direction, and ABCD is perpendicular to x direction. ಅಂದ್ರೆ ABCD through ಹೋದ್ರೆ ತಾನೆ along x ಹೋದಂಗ ಆಗುತ್ತೆ, ಕರೆಕ್ಟಾ? So along ABCD means it is parallel to x, it is along x direction. Okay, rho into u into area of ABCD is length into height. What is length? dy. Height is dz. So rho u into dy into dz is what? Mass of the fluid entering phase ABCD. Now ABCD is entered, okay. Then what is the mass which is leaving the element? That is, then mass of the fluid leaving the phase EFGH per second is equal to, so EFGH ಗೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ? ಸೊ ಇದು ಸೇಮ್ ಇರುತ್ತೆ, rho u into du dy by dy into dz. That will be same because it is the entered phase, no, entered the fluid entered from this phase, no. So that will be same. Plus it has to do a work done of this portion, so it is moving in this direction x. Okay, if we enter this only, so who will, it has did some work, no, or it is some energy is inputted in that. Okay, so that energy which is gained, so CV ಅಂತ ಹೇಳಿ ನಾವೇನು ಯೂಸ್ ಮಾಡಿ ಕಂಟ್ರೋಲ್ ವಾಲ್ಯೂಮ್ ಅಂತ ಏನು ಹೇಳಿದ್ವಲ್ಲ ಕಂಟಿನ್ಯೂಟಿ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ, ಸೊ ಅಲ್ಲಿ the energy increase ಆಗುತ್ತೆ ಅಂತ ಏನು ಓದಿದ್ವಲ್ಲ. So that energy will be increased. Why? It has to move from here to here, so energy is gaining. Okay, so that energy ಹೆಂಗೆ ಕೊಡ್ತೀವಿ? So that energy is given by partial differentiation of x, because it has to move in the direction of x, right? Okay, partial differentiation dou by dou x into this only, rho u dy dz in the direction of dx. Okay, please understand here. If it was offline it would be better. It's okay, no problem. See, mass of the fluid entering the phase ABCD is what? Rho into u into dy into dz. So this is the amount of quantity of water entering it. Okay, it will enter ABCD, but it has to move. It has to move, right? Move to a distance of what? Dx, to leave EFGH. A water quantity of amount of water has to do ಏನು ವರ್ಕ್ ಮಾಡಬೇಕು, ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕು? dx ಅನ್ನೋ ಡಿಸ್ಟೆನ್ಸ್ ವರೆಗೂ ವರ್ಕ್ ಮಾಡಿ EFGH ಇಂದ ಹೊರಗಡೆ ಬರಬೇಕಲ್ವಾ? So that work we are calculating here. So it is in the direction of what? X, in the direction of x alva. So this energy, that is rho u dy dz, it will go in the direction of x, right? So partial differentiation of x with the mass of the fluid entering the phase ABCD along dx. Okay, dou by dou x of rho u dy dz dx. This you have to remember whenever you are asked to find the continuity equation for 3D. Now we got to know the mass of fluid entering the phase ABCD and the mass of fluid leaving the phase EFGH. Correct. Now what we have to find? The gain of mass in x direction. Yes, whenever it moves from phase AB, see here the phase AB to EF, it has gained its energy. Okay, AB ಇಂದ EF ವರೆಗೆ ಬರೋದ್ರಲ್ಲಿ ಅದೇನಾಗಿದೆ, ಎನರ್ಜಿ ಗೇನ್ ಆಗಿದೆ, because it has to move toward distance of dx. Okay, so mass through ABCD minus mass through EFGH per second ಮಾಡಿದಾಗ ನಮಗೆ ಆಕ್ಚುಯಲ್ ಗೇನ್ ಏನಾಗಿದೆ ಅನ್ನೋದು ಸಿಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ಸೊ mass through ABCD ಏನಪ್ಪ, mass through ABCD rho u into dy into dz minus mass through EFGH. So this is rho u into dy dz plus partial differentiation of, so minus bracket haki, this is the first step, plus partial differentiation of rho u dy dz into dx. Then after rho u dy dz minus rho u dy dz plus into minus, again minus partial differentiation of x into rho u dy dz into dx. Then this step will come. After that this will get cancelled. So what is remaining? Partial differentiation of rho u into dy dz dx, right? That is negative. Okay, so the gain of mass in x direction is partial differentiation of rho u dy dx and dz. So this is the gain of mass in x direction when the mass of fluid entering from ABCD to come near EFGH, and it will move again, it will leave the phase EFGH. So this is the mass gained by the fluid, okay, while it is moving through a distance of dx. So next, similarly the net gain in mass in y direction. So what we did is, it is just in one direction, that is x direction. Okay, so whatever we did till now, it is in x direction. The same will be happened in z direction, the same will happen in y direction. Okay, the same, the mass of entering ADEH, okay, when water enters like this in the direction of z, and when it leaves BUGF, same procedure we have to do, and also in y direction we have to take this area. Okay, when you take in all the three directions, what will be the result? The result will be same, that is rho by partial differentiation of which direction we will take, that direction. If we take in x direction, it is x. If we take in y direction, it will be y. If we take in z direction, it will be z. That is rho u into dx dy dz. Okay, so similarly the net gain in mass in y direction is partial differentiation of y into, so u for x speed, v for what, y, and w for z. Remember this. Okay, similarly the net gain of mass in y direction is what? Partial differentiation of y rho v dx dy dz, and in z direction partial differentiation of z rho into w dx dy dz. Okay, so all are in negative factor, right? Now, so we found out the net gain mass in x, y and z directions. So when we make the total, what we get? The net gain of masses of the fluid element will be, what will be the net gain masses? It will be partial differentiation of x into rho u plus partial differentiation of y into rho v plus partial differentiation of z into rho w. So it minus na ಹೊರಗಡೆ ತಗೊಂಡು we will add the three equations, this one and also in the x direction that one. If we add them, we will get the net mass, the net gain of masses in the fluid element in the three directions, that is partial differentiation of rho u in the direction of x, partial differentiation of y in the direction of v, that is y, partial differentiation of z with it is rho w dx dy dz. So this is the net gain of masses. Okay, so what we did till now, we calculated the mass of the fluid entering ABCD per second, that is rho u into dy dz. Then we calculated the same amount of fluid ejecting from here, that is EFGH. So once we calculated the mass of the fluid leaving EFGH, we got what? The net gain in the x direction. Then we found out the similarly the net gain in y direction and also in z direction. So next we will add all the three, then we will get this equation. Okay, now we will apply the principle of conservation of mass. Since the mass is neither created nor destroyed in the fluid element, the net increase of mass per unit time in the fluid element must be equal to the rate of increase of mass of fluid in the element. Okay, you know, the mass is neither created nor destroyed, then the net increase of mass per unit time in the fluid element must be equal to the rate of increase of mass of fluid in the element. Okay, so what they are telling, wait, since the mass is neither be created, so the law of conservation of movement ಏನು ಹೇಳುತ್ತೆ, it is neither be created nor be destroyed. ಮತ್ತೆ ನೆಟ್ increase energy ಎಲ್ಲಿಂದ ಬಂತು? The net increase energy, the net increase of mass per unit time in the fluid, okay, must be equal to ಎದಕ್ಕೆ? The net increase of mass per unit time in the fluid element must be equal to the rate of increase of mass of fluid in the element. Okay, the rate of increase of mass of fluid in the element. But mass of fluid in the element is what? Its density in with the direction dx dy dz, and its rate increase with the time, that is partial differentiation of t into rho into dx dy dz, or simply we can write as partial differentiation of t with respect to, that is dou rho by dou t into dx dy dz. Then so with this expression and also the net gain mass, we will equate both. Okay, so this equation, the net gain of masses, into this equation, that is dou p by dou t, dou rho by dou t dx dy dz, what we do, we will equate that two expressions. Then what we will get, we will get, that is rho, partial differentiation of rho, that is dou rho by dou t, then partial differentiation of x into rho u plus partial differentiation of y into rho v plus partial differentiation of z into rho w is equal to 0. Okay, here we will cancel both dx dy dz on the both sides. So what is remaining, we will take it to one side, and when we simplify, we will get this one. Okay, heng bantidu? Since what does the law of conservation of mass tells, the mass can neither be created nor be destroyed, correct? When the law of conservation of mass, so neither be created nor be destroyed, okay, but we got the net gain, right? Net gain ಎಲ್ಲಿಂದ ಬಂತು? So the net increase of mass per unit time in the fluid element, so net gain ಆಯ್ತು ತಾನೆ, that is negative of partial differentiation of x rho u into dx dy dz in x direction. So when we do total, this one is right, the net gain. So from where this net gain came, they are telling that this net gain, the net increase of mass per unit time in the fluid element must be equal to the rate of increase of mass of fluid in the element. So adenu ABCD phase inda EFGH ವರೆಗೆ ಏನು ಬಂತಲ್ಲ in the direction of dx, ಸೊ ಅಲ್ಲಿ ಟೈಮ್ ತಗೊಳುತ್ತೆ, ABCD ನ ಬರಕ್ಕೆ EFGH ಟೈಮ್ ತಗೊಳುತ್ತಲ್ವಾ, ಸೊ ಆ ಟೈಮ್ ಅಲ್ಲಿ ಅದೆಷ್ಟು ಮೂವ್ ಆಗಿರುತ್ತೋ ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, so but mass of fluid in the element is, what is that? It is governed by rho in the direction of dx divide dz, and it is the rate of what? Partial differentiation of t into rho into dx divide dz. So with this element, that is rho by dou t dx divide dz, we will equate the expression of the net gain of masses. When we equate it, then this dx divide dz will be cancelled, and we will get this equation, that is partial difference dou rho by dou t plus partial differentiation of x into rho u, partial differentiation of y into rho v, partial differentiation of z into rho w is equal to 0. So this equation, the equation which I am showing here, no, so this equation is what? The continuity equation. Okay, this is the continuity equation in Cartesian coordinates. Okay, and it is a general form. Okay, this equation is continuity equation in 3D. Okay, now this equation is applicable to steady and unsteady flow, uniform and non-uniform flow, and compressible and incompressible flow. So this equation steady flow ಬಂದಾಗ ಯಾವ ತರ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಇದೇ equation compressible ಬಂದಾಗ ಹೆಂಗೆ, ಇದೇ equation uniform non-uniform flow ಬಂದಾಗ ಹೆಂಗೆ, with the respective conditions with that definition. Steady flow ಅಂದ್ರೆ ಏನು? Dou rho by dou t is equal to what? 0. It will not change with time. I'll show you. Will you understand? So see, that equation is the continuity equation in Cartesian coordinates. So for steady flow, this dou rho by dou t is what? 0. What is that? This is the equation. If this is satisfied, it is steady flow. If that is steady flow, the equation will be reduced to this one, that is dou rho by dou t will be 0, then partial differentiation of x into rho u, partial differentiation of y into rho v, partial differentiation of z into rho w is equal to 0. So this is the continuity equation in 3 dimension for steady flow. Okay, this is the continuity equation for steady flow. What if the fluid is incompressible? Then the rho is constant. For incompressible fluids, density will not change, right? So the density is constant, and the above equation becomes what? Rho u by rho x plus dou v by dou y. It is dou u by dou x plus dou v by dou y plus dou w by dou z. So this you will not get. It is constant means it will be cancelled, right? So dou u by dou x plus dou v by dou y, dou w by dou z is equal to 0 for incompressible fluids. So this is the equation for continuity equation in 3D for incompressible equation. You have to remember the equation. What if the continuity equation in 3D for a 2-dimensional flow? So when the continuity equation is for 2-dimensional flow, then either u is equal to 0, okay, or v is equal to 0, or w is equal to 0. So here we author directly took w is equal to 0, and the continuity equation in 2 dimension is what? Dou u by dou x plus dou v by dou y is equal to 0. So hence this continuity equation in 3 dimensions can be reduced to 2 dimensions by leaving or by converting one of the dimension component to 0. So what is the 2-dimensional equation? That is dou u by dou x plus dou v by dou y is equal to 0. So once you write it and you read again, you will get to understand. So this was about the continuity equation in 3 dimensions. So how will be the question will be formed? I'll show you the one question. So the following cases represents the 2 velocity components. See here, they are giving 2 velocity components. Determine the third component of velocity such that they satisfy the continuity equation. Okay, so the u component is given, that is it is determined direction is x direction. V component is given, okay, and second condition v is given, w is given. So what in this question they are telling means, The following case represent two velocity components. Okay. Determine the third component of velocity such that they satisfy the continuity equation. So u and v ಕೊಡ್ತಾರೆ w ಕಂಡುಹಿಡಿಯಬೇಕು. ಇಲ್ಲಿ ಕೆಳಗಡೆ ಏನು v and w ಕೊಟ್ಟಿದ್ದಾರೆ x ಕಂಡುಹಿಡಿಯಬೇಕು. So what we know, the continuity equation we know, if they do not give any condition, then they are giving, then you have to follow this equation, the continuity equation for incompressible fluid, that is dou u by dou x plus dou v by dou y plus dou w by dou z. So what is u? U is given as x square plus y square plus z square. So dou u by the partial differentiation of u ಏನಾಗುತ್ತೆ? So dou u by dou x is equal to differentiation of x square is 2x. Differentiation of y square with respect to x, it will be constant, it is 0. Differentiation with respect to z, it will be 0. So differentiation of u with respect to x is 2x. Then differentiation of v with respect to y. Okay, here, as here y term is there, then what will it be? Y square, what? 2xy minus y. Okay, y is only one term, so differentiation of y will be 1 with respect to 1. So 2xy minus z square plus x. Okay, ಅದೇ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಇನ್ ವಿತ್ ಎಕ್ಸ್ ಟರ್ಮ್ ಇದ್ರೆ 2x ಆಗುತ್ತೆ. ವಿ ಅಲ್ಲಿ ಇದ್ದಾಗ y ಟರ್ಮ್ ಇದ್ರೆ ಮಾತ್ರ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಆಗುತ್ತೆ. y ಟರ್ಮ್ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು 0 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿವರೆಗೆ y ಟರ್ಮ್ ಇದೆ, y ಟರ್ಮ್ ಇದೆ, y ಟರ್ಮ್ ಇದೆ. ಸೊ y ಟರ್ಮ್ ಇದ್ದು y ಸ್ಕ್ವೇರ್ ಇದ್ದು 2y ಆಗುತ್ತೆ, y ಇದ್ದು 1 ಆಗುತ್ತೆ, ಇಲ್ಲಿ y ಇದ್ದು 1 ಆಗುತ್ತೆ. ಸೊ 2xy minus z square plus x. So ಇದು dou u by dou x, this is dou v by dou y. So substituting dou u by dou x and dou v by dou y in this continuity equation, what we will get? So 2x plus 2xy minus z square plus x dou w by dou z is equal to 0. So once we want this, no, send this all to that side. So dou w by dou z is equal to minus 3x plus, so 2x plus x is minus 3x minus 2xy plus z square, or dou w is equal to minus 3x minus 2xy plus z square into dx. So this is how we can solve the problem. Okay, so now what we found? We found dou w is equal to minus 3x minus 2xy plus z square into dz. So dou z, what is in the question? We have to find w. So it is in the form of differentiation. We want w. What we have to do? We have to integrate. So when we integrate rho w, okay, dou w, okay, when we integrate dou w, we will get this integration and this differentiation. Integration and differentiation get cancelled, and we will get the value of the w value. So integration of this, what will happen when we integration dou w? We will get w is equal to integration of minus 3x. So minus will be as it is, integration of 3x with respect to z, it will be 3x into z, correct? Next minus 2xy, integration of 2xy with respect to dou z is what? So you should be very good in mathematics. 2xy z, so plus, what is they are giving? Integration of z square, what will be? Z cube by 3, okay, plus constant of integration. So this is your equation if you integrate it dou w. Okay, so this plus c, so this constant of integration will be there, no? So ಅದೇನಾಗುತ್ತೆ, constant of integration ಇದು z ಅಲ್ಲಿ ಇದೆ. So constant of integration should be in other two direction, that is it is a function of f of x comma f of y. So I'll tell you, show you, see here. So integration on both the sides, integrate it. So when we integrate, we will get the value of w, that is minus 3xz minus 2xyz plus z cube by 3 plus constant of integration. So this constant of integration will be a function of x and y, that is f of x comma y. Okay, so you have to write directly that f of x comma y is the answer, or plus c you should not write, you should write as plus f of x comma y. So this is your answer. Okay, case 2. how we can solve the case 2? So case 2, what I have given, v is equal to 2y square. Okay, what we have to do, we know this formula, that is continuity equation for incompressible formula. It is dou u by dou x plus dou v by dou y dou w by dou z is equal to 0. ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, v ಕೊಟ್ಟಿದ್ದಾರೆ, w ಕೊಟ್ಟಿದ್ದಾರೆ. we have to find dou u by dou x. find ಆದ್ಮೇಲೆ dou u by dou x ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ u ಸಿಗುತ್ತೆ. so this dou v by dou x ಅಂದ್ರೆ we have to integrate or differentiate this with respect to y. so when we differentiate this with respect to y, what we will get? So dou v by dou y will be 4y, correct? So 2y square allow 2 to the 4y. So when we differentiate w, what we will get? 2xyz alva. So differentiation of z, so z will be 1, no, so it will be 2xy. Then substitute them in this equation, you will get dou u by dou x. So dou u by dou x as minus 4y minus 2xy into dz. So integrate it, you will get u is equal to minus 4xy minus x square y plus, so constant of integration. So idu x ಅಲ್ಲಿ ಇದೆ, u term ಅಲ್ವಾ. so u term ಇದ್ದಾಗ constant of integration ಎದರಲ್ಲಿ ಇರುತ್ತೆ? y is a function of y and z. if it is u, the constant of integration will be f of u ಏನು x term ಅಲ್ವಾ, x ಬಿಟ್ಬಿಡ್ಬೇಕು, y, z ಮಾಡಬೇಕು. ಓಕೆ, v ಅಲ್ಲಿದ್ರೆ y ಬಿಟ್ಬಿಡ್ಬೇಕು, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್ ಯಾವುದು? z, x ಅಂತ ಬರೀಬೇಕು. ಓಕೆ, ಇಫ್ ಇಟ್ ಈಸ್ w, we know we have to write f, x, f of x, y. so the constant of integration will be other two mutually perpendicular ಅಲ್ವಾ. u ಇದ್ರೆ yz ಇರುತ್ತೆ, v ಇದ್ರೆ xz ಇರುತ್ತೆ, w ಇದ್ರೆ x and y ಇರುತ್ತೆ. so this type simple problem they will give, you have to understand the concept and you have to solve the problem where in the continuity equation for 3D. so like this only one equation will be given, so you have to partially differentiate it. if they give any condition that they will provide a condition that it is an incompressible fluid flow, then you have to use the equation which I have shown here. if they give it is for steady flow, then we have to use the equation for steady flow. where is that? I will show you. so this you have to remember. so for steady flow, what is the equation? for incompressible flow, what is the equation? if they give the 3 dimensions and they are specifying it is 2-dimensional flow, then you have to use dou u by dou x plus dou v by dou y is equal to 0. okay, you remember this, most of the questions will be from this only. okay, if they give steady flow, remember this one. if you know this, you can reduce this to 2 dimensions easily, that is dou w by dou z 0 ಆದರೆ is equal to 0. so this is how we solve the problem for in 3D for the continuity equation in 3D concept. so next, the stream potential function, velocity function, and another small concept of flow net is there, which I will deal in the next session. Thank you.